far beyond the thin blue atmosphere of Earth, beyond the silent orbit of the Moon, and beyond the wandering paths of the planets, there exists a structure so enormous that the human mind struggles to hold it all at once. A galaxy is not simply a collection of stars, it is a drifting civilization of suns, a vast, rotating ecosystem of light, gravity, memory, and time. And tonight, as the world grows quieter and the hours slowly soften around you, we begin a journey through these immense cosmic islands, moving gently through the deep architecture of the universe itself. If you could leave Earth behind and travel outward at impossible speed, the familiar patterns of the night sky would slowly begin to change. The constellations humans have carried for thousands of years would stretch apart and dissolve. The stars that appear close together from our small position on Earth are, in reality, separated by astonishing distances. Space is mostly emptiness, a calm and almost unimaginable emptiness, and yet scattered throughout that darkness are galaxies, billions upon billions of them, each containing billions or even trillions of stars. For most of human history, nobody knew galaxies even existed. Ancient civilizations looked into the night sky and saw a pale band of light stretching across the darkness. The Romans called it the Via Lactea, the Milky Way. To the naked eye, it appeared soft and cloudy, like spilled milk across black stone. Some cultures imagined it as a river, others believed it was smoke from celestial fires, or the pathway of souls moving between worlds. Few could have guessed that this faint glowing band was not a cloud at all, but the inside view of an enormous spiral galaxy containing perhaps 400 billion stars. The realization came slowly, in the 17th century, when early astronomers pointed primitive telescopes toward the Milky Way. They discovered something deeply unsettling and beautiful. The pale fog overhead was made of countless individual stars packed together so densely that human eyes could not separate them. Suddenly the universe became larger than anyone had imagined. Not just larger by a little, but larger in a way that permanently altered humanity's sense of itself. And yet even then, people still believed the Milky Way was the entire universe. Beyond it lay mysterious fuzzy shapes known as nebulae, small spirals and glowing smudges that telescopes could barely resolve. Some astronomers suspected these objects were nearby clouds of gas forming stars. Others proposed something far stranger. They wondered whether these faint spirals might actually be entire universes of their own, impossibly distant collections of stars floating far beyond the Milky Way. For decades, nobody knew the answer. Then, in the 1920s, an astronomer named Edwin Hubble studied a faint spiral known as the Andromeda Nebula. Using careful measurements of starlight, he discovered that Andromeda was far too distant to exist inside the Milky Way. It was not a nearby cloud. It was an entirely separate galaxy, a colossal rotating city of stars located more than 2 million light-years away. In one quiet moment of observation, the known universe expanded forever. It is difficult to fully appreciate what this discovery meant psychologically. For thousands of years, humanity imagined itself living inside the universe. Then suddenly, the Milky Way itself became only one galaxy among countless others. The human story shrank dramatically. Earth became smaller, the Sun became smaller. Even our galaxy became just one drifting structure in an ocean with no visible shore. And strangely, many people found this comforting. There is a certain peace in cosmic scale. The worries that dominate ordinary life begin to soften when placed beside distances measured in millions of light-years. Entire human civilizations rise and disappear in less time than it takes some stars to complete a single orbit around their galactic centers. The universe moves slowly, patiently, almost indifferently. And yet within that indifference there is also extraordinary beauty. Most galaxies are shaped by gravity into recognizable forms. Some are spirals, elegant and rotating, with curved arms winding outward like luminous hurricanes. Others are elliptical galaxies, older and calmer, where stars drift in smoother, more random paths. And some galaxies are irregular, distorted by collisions and ancient gravitational encounters. No two are exactly alike. each carries its own history written in starlight. The Milky Way itself is a barred spiral galaxy. If viewed from above, it would resemble a vast glowing whirlpool suspended in darkness. Its spiral arms stretch across more than 100,000 light-years. Inside those arms, new stars are constantly being born within cold clouds of gas and dust. Massive blue stars shine briefly before exploding in violent supernovas. Smaller stars, like our Sun, burn more steadily for billions of years, and between those stars lies enormous silence. If the Sun were the size of a grain of sand, the nearest star would still be miles away. Galaxies only appear crowded from a distance. In reality, the space between stars is so immense that direct collisions between individual stars are surprisingly rare, even when galaxies themselves collide. When two galaxies pass through one another, their stars mostly drift untouched through vast, empty regions. Gravity slowly reshapes everything over millions of years, bending spiral arms, triggering waves of star formation, and altering entire galactic structures with almost graceful slowness. One day, the Milky Way will collide with the Andromeda Galaxy. Not tomorrow, not soon. About 4 billion years from now, these two immense spirals will begin a slow gravitational dance. Their shapes will distort. Great rivers of stars will stretch across the darkness. Over time, they will merge into a single larger galaxy, sometimes called Milky Way by astronomers. By then, Earth itself may no longer exist in its current form. The Sun will be aging. Oceans may already be gone. Yet the galaxies will continue their quiet movement through space, unconcerned with the small histories that once unfolded beneath our skies. There is something deeply humbling about that timescale. Human beings experience life through days, seasons, and decades. Galaxies experience reality through epochs. Their rotations take hundreds of millions of years. The light from distant galaxies traveling toward your eyes tonight may have begun its journey before human civilization existed. Some of the galaxies visible through powerful telescopes no longer exist in the form we see them. Their ancient light is still arriving, carrying images from a universe long gone. In a sense, astronomy is a form of time travel. Every glance into deep space is also a glance backward through history. The farther outward we look, the younger the universe becomes. Nearby stars appear as they were years ago. Distant galaxies appear as they were millions or billions of years ago, and at the edge of observable space lies faint radiation from the early universe itself, ancient light released shortly after the cosmos first became transparent. The universe remembers everything through light, and among the most mysterious objects hidden inside galaxies are the enormous gravitational entities resting quietly at their centers. Invisible structures so powerful that entire galaxies revolve around them like leaves circling a drain in slow motion through the dark. These are supermassive black holes, cosmic objects so strange that even now, after decades of study, they remain partly hidden behind the limits of human understanding. At the center of the Milky Way resides one of these immense objects, known as Sagittarius A star. It cannot be seen directly in ordinary light because clouds of dust veil the galactic core from our position inside the spiral arms, but astronomers have watched the stars near it move in tight, rapid orbits, circling an invisible presence with extraordinary mass. Something there contains the weight of millions of suns compressed into a region smaller than our solar system. And yet black holes are not cosmic vacuum cleaners swallowing everything around them. In many ways, they are quieter than popular imagination suggests. A black hole only exerts the same gravitational pull as any other object of equal mass. If our Sun were somehow replaced by a black hole of identical mass, Earth would continue orbiting almost exactly as before, though frozen forever without sunlight. The true strangeness of black holes lies not in their hunger, but in the way they distort reality itself. Near a black hole, gravity becomes so intense that time begins to slow down. Not metaphorically, literally. According to Einstein's theory of relativity, clocks closer to strong gravity tick more slowly compared to clocks farther away. Around supermassive black holes, this effect becomes extreme. Time and space stretch and bend together like fabric under enormous weight. It is one of the quiet wonders of the universe that reality itself is flexible. The galaxies scattered across the cosmos are shaped not only by stars and gas, but by invisible structures humanity still cannot fully explain. Modern astronomy suggests that most of the mass inside galaxies is made of something called dark matter. No one has ever directly seen it. It emits no light. It does not reflect or absorb radiation in ordinary ways. Yet galaxies rotate too quickly to hold themselves together using visible matter alone. Something unseen provides additional gravity, forming enormous halos around galaxies like invisible skeletons supporting luminous bodies. In a strange sense, galaxies may be built mostly from something humanity has never touched. This realization has changed the emotional atmosphere of modern astronomy. The universe is no longer simply vast. It is also mysterious at its core. The stars, planets, and glowing nebulae visible through telescopes may represent only a small fraction of what truly exists. Most of the cosmos appears hidden, and still, the visible parts are already almost beyond comprehension. Some galaxies contain only a few million stars. Others contain trillions. There are giant elliptical galaxies so enormous that they dominate entire clusters containing thousands of smaller galaxies bound together by gravity. Between those galaxies stretches intergalactic space, cold and dark and nearly empty, where a traveler might drift for millions of years without encountering a single star. The distances between galaxies are so immense that ordinary language begins to fail. Light itself, the fastest thing known in the universe, requires over 2 million years to travel from the Andromeda galaxy to Earth. The light leaving Andromeda tonight will arrive long after every human alive today has disappeared into history. Even messages traveling forever at the speed of light become tiny and slow when measured against galactic space. Perhaps this is why galaxies inspire such unusual feelings in people. Awe, certainly, but also silence. When confronted with something truly immense, the mind often becomes still. Modern neuroscience has found that experiences of awe can alter human perception in subtle ways. People exposed to vast natural environments, enormous architecture, or cosmic imagery often report a softened sense of self. Personal anxieties briefly shrink. Time feels different. Attention widens outward. The brain, confronted by overwhelming scale, temporarily releases its usual obsession with immediate concerns. Looking at galaxies may gently reorganize the emotional landscape of the mind. Maybe this explains why humans across history have always returned to the stars during periods of uncertainty. Ancient sailors navigated by them. Philosophers searched them for meaning. Poets imagined entire worlds hidden among them. Even now, in brightly lit modern cities, people still pause when they encounter a truly dark sky. Something ancient awakens in the nervous system when the universe becomes visible overhead. For most of human existence, galaxies were not scientific objects. They were emotional presences. Long before telescopes existed, the night sky shaped religion, agriculture, migration, storytelling, and the human sense of time itself. Entire civilizations rose beneath the turning stars. In ancient deserts, forests, mountains, and oceans, people watched the Milky Way slowly wheel across the darkness year after year, generation after generation, never realizing they were living inside a galaxy moving silently through space at hundreds of kilometers per second. Even now, the Milky Way is in motion. Our solar system orbits the galactic center at extraordinary speed, completing one full rotation roughly every 230 million years. The last time Earth occupied this exact position within the galaxy, dinosaurs still walked beneath prehistoric skies. Entire branches of evolution have unfolded during a single galactic year. Human history, by comparison, is almost impossibly brief. Written language emerged only moments ago on cosmic timescales. The pyramids of ancient Egypt were built only yesterday relative to the age of the galaxy. And modern civilization occupies such a thin slice of time that, from the perspective of the Milky Way, all of recorded human history resembles the brief flicker of a single firefly. Yet within that tiny flicker, conscious beings learned to observe the universe. This may be one of the most remarkable facts of all. Inside an ordinary spiral galaxy, around an ordinary star, on a small rocky planet covered in oceans, matter slowly organized itself into living organisms capable of wondering about galaxies. Hydrogen formed stars. Stars forged heavier elements. Those elements formed planets. Planets produced chemistry complex enough to generate life. And eventually, somewhere within the long unfolding of biological evolution, the universe became capable of observing itself. There is something quietly beautiful about that chain of events. The calcium in human bones was forged inside ancient stars. The iron in human blood originated in stellar explosions billions of years ago. In the most literal physical sense, every person is composed of recycled galactic material. The atoms moving through your body tonight once drifted inside stars long vanished from existence. Carl Sagan once described humans as star stuff, and although the phrase became famous, it remains scientifically true in a very deep way. Galaxies are not separate from us. We are products of galactic evolution itself. Perhaps this is why deep space can feel strangely intimate despite its scale. The universe appears cold from a distance, yet everything familiar emerged from its processes. Every tree, ocean, memory, animal, city, and human thought ultimately traces back to events unfolding inside galaxies over billions of years. Even the oxygen entering your lungs tonight was forged in stellar interiors long before Earth existed. The cosmos is not merely around us, it is within us. And still, despite everything modern astronomy has discovered, galaxies continue to conceal astonishing mysteries. Some spiral structures appear too orderly. Some galaxies stop forming stars for reasons scientists do not fully understand. Others produce enormous jets of radiation from their central black holes, launching streams of energy across hundreds of thousands of light-years into intergalactic space. The deeper humanity looks into the universe, the more questions emerge from the darkness. In recent decades, telescopes have become so powerful that astronomers can now observe galaxies forming in the early universe. These ancient structures appear faint and distorted, their light stretched by cosmic expansion during journeys lasting billions of years. Looking at them is like staring through layers of time toward the beginning of existence itself. And what scientists found was surprising. The young universe appears to have formed galaxies remarkably quickly. Only a few 100 million years after the Big Bang, enormous collections of stars already existed where darkness once dominated. It is as though the cosmos possessed an ancient urgency during its earliest moments, rapidly assembling structure from simplicity. Tiny fluctuations in primordial matter slowly grew under gravity, gathering gas into immense rotating systems that would eventually become galaxies. Everything familiar emerged from those first gravitational whispers. At the beginning, the universe contained almost nothing except hydrogen, helium, radiation, and darkness. No planets, no oceans, no life, no trees moving in wind beneath moonlight. The heavier elements required for complex chemistry did not yet exist. They had to be forged slowly inside stars over immense stretches of time. Galaxies became the great factories of creation. Inside their stellar furnaces, hydrogen atoms fused together under extraordinary pressure, releasing light and heat into surrounding space. Larger stars produced carbon, oxygen, silicon, magnesium, and iron. Then, when those stars died in catastrophic explosions called supernovas, these newly forged elements scattered outward into the galaxy, enriching enormous clouds of gas and dust from which future stars and planets would form. Every generation of stars changed the chemistry of the universe. Early galaxies were probably strange places compared to the modern Milky Way. Many contained enormous blue stars burning at terrifying brightness. These stars lived fast and died young, flooding surrounding regions with ultraviolet radiation before exploding after only a few million years. The universe back then may have glowed with a harsher, more violent beauty. Over time, galaxies matured. The rate of star formation gradually slowed. Stellar populations aged. Spiral structures stabilized. Smaller galaxies merged into larger ones through countless gravitational encounters. The cosmos settled into the quieter rhythm astronomers observe today. Even the universe itself has cooled dramatically since its fiery beginning. Space is now filled with a faint temperature only a few degrees above absolute zero. Cosmic history is, in many ways, the story of gradual cooling. There is something calming about that idea. The universe began in unimaginable heat and brightness, yet across billions of years it softened into darkness, structure, and silence. Galaxies drift now through cold intergalactic space like lanterns floating across a black ocean. Some galaxies are especially peaceful. Astronomers occasionally discover isolated spiral galaxies that have remained largely undisturbed for billions of years. Their stars orbit quietly in stable patterns. New stars form slowly within calm molecular clouds, little changes from 1 million years to the next. If intelligent civilizations exist inside such galaxies, their skies may appear extraordinarily serene compared to regions shaped by constant collisions and violent activity. Other galaxies are chaotic beyond imagination. In so-called starburst galaxies, stars form at explosive rates hundreds of times faster than in the Milky Way. Massive stellar nurseries illuminate entire regions with intense blue-white light. Supernovas erupt frequently. Powerful winds generated by young stars push gas outward into space. These galaxies burn with temporary brilliance, consuming their star-forming material rapidly before eventually quieting again. The universe contains both frenzy and stillness at once. Even within our own galaxy, environments vary enormously. Near the galactic center, stars crowd together in dense populations, moving rapidly under intense gravity. Radiation levels rise. Ancient globular clusters orbit like luminous swarms containing some of the oldest stars in existence. Farther outward, in the quieter spiral arms where the sun resides, stars are more widely spaced. Here, cosmic conditions may have been gentle enough for complex life to emerge over long, uninterrupted periods. In a way, humanity exists in one of the calmer neighborhoods of the Milky Way. If Earth were located too close to the galactic center, frequent supernovas and energetic radiation might repeatedly sterilize planetary surfaces. Too far outward, and there might not have been enough heavy elements available to form rocky planets at all. Our solar system occupies a strangely balanced position. Not too crowded, not too empty. Astronomers sometimes call this region the galactic habitable zone. It is a reminder that even on cosmic scales, existence depends upon delicate conditions. Galaxies are not random collections of stars scattered meaninglessly through space. Their structures influence the possibilities of planetary systems, chemistry, and perhaps consciousness itself. And still, despite all this complexity, galaxies remain astonishingly beautiful to observe. Modern telescopes reveal them in exquisite detail. Spiral arms glow with pink clouds where stars are born. Dark lanes of dust curve through luminous disks like rivers of shadow. Elliptical galaxies shine with smooth golden light from ancient stellar populations. Some interacting galaxies stretch into long tidal streams resembling celestial brushstrokes painted across blackness. Yet the true experience of a galaxy is not visual alone, it is psychological. To contemplate a galaxy is to confront scale beyond ordinary intuition. Human brains evolved to navigate forests, rivers, weather, faces, and social groups. We did not evolve to emotionally process structures spanning 100,000 light-years. And yet somehow, the mind still tries. Perhaps this effort itself changes us. There is evidence that astronomy influences human thought in subtle philosophical ways. Studies suggest that exposure to cosmic imagery can increase feelings of connectedness and reduce rigid self-focus. When people contemplate the age and scale of the universe, daily frustrations often appear less permanent. Perspective widens. The mind becomes quieter, not because human life loses meaning, but because meaning expands. A single galaxy contains more stars than there are grains of sand on many beaches of Earth. Around many of those stars orbit planets. Around some of those planets, perhaps oceans shimmer beneath alien moons. Perhaps winds move through forests unlike any seen on Earth. Perhaps somewhere, beneath unfamiliar constellations inside distant galaxies, Conscious beings are also looking outward into the dark, wondering whether they are alone. The silence of the universe does not necessarily mean emptiness. It may simply mean distance. Signals traveling between galaxies would require millions of years to arrive. Entire civilizations could rise and disappear before a single greeting crossed intergalactic space. The cosmos may contain countless stories unfolding simultaneously, each separated by such enormous expanses of time and distance that they remain forever isolated from one another. There is a certain melancholy in that possibility, but also beauty. Galaxies remind us that existence is not centered around any single world. Life, if it exists elsewhere, may emerge quietly in scattered corners of the cosmos, each civilization carrying its own myths, sciences, fears, music and dreams beneath different skies. And meanwhile, above Earth tonight, the Milky Way continues its slow rotation through darkness. Most people living in modern cities rarely see it clearly anymore. Artificial lights wash away the deeper sky. Entire generations grow up without witnessing the full brightness of the galaxy overhead. Yet in remote deserts, mountain ranges, and open oceans, the Milky Way still appears as an immense river of stars stretching from horizon to horizon. For a moment, under such skies, human time begins to feel different. The nervous system slows, thoughts become quieter. The universe no longer feels abstract. It feels present, ancient, watching silently from every direction at once. And hidden within that glowing river are stars already dead, stars still forming, wandering planets without suns, invisible black holes, and clouds of dust that may one day become entirely new solar systems. Some of those clouds are so enormous that they span hundreds of light years. Seen through powerful telescopes, they resemble drifting continents of shadow and light suspended inside the galaxy. Within them, gravity slowly gathers cold hydrogen gas into denser regions. Over immense stretches of time, these regions collapse inward, heating gradually until nuclear fusion ignites and a new star is born. Star formation is surprisingly quiet at first. There is no sound in space as humans experience it on Earth. No roaring fire, no explosive crack. Only darkness, pressure, radiation, and slow transformation unfolding over millions of years. A newborn star emerges gently from its cloud, illuminating surrounding dust with pale colors, blue, crimson, gold, and violet, creating some of the most beautiful structures in the known universe. Astronomers sometimes refer to these regions as stellar nurseries. It is a peaceful phrase for processes so vast and powerful that they reshape entire portions of galaxies. Around many young stars, disks of leftover material continue orbiting after formation. Inside these spinning disks, grains of dust collide and stick together. Pebbles become rocks. Rocks become worlds. Over time, planets emerge from drifting debris through countless impacts and gravitational encounters. The Earth itself formed this way roughly 4.5 billion years ago inside one quiet corner of the Milky Way. Everything familiar began as dust orbiting a young star, and perhaps somewhere tonight, inside distant galaxies beyond human sight, other worlds are forming beneath unfamiliar suns. Oceans may already be condensing on cooling planetary surfaces. Atmospheres may be thickening. Lightning may be flashing across alien skies where no conscious creature yet exists to witness it. Galaxies are filled not only with stars, but with possibilities. One of the most haunting facts in astronomy is that many stars visible in the night sky are older than Earth itself. Some formed long before the Sun existed. Their light traveled across space, while continents shifted, species evolved, and human civilization slowly emerged. Ancient starlight enters human eyes every night without announcing its age. There is something deeply calming about this continuity. Human lives are brief, but the cosmos carries on with extraordinary patience. Stars are born, stars die, galaxies rotate, new worlds emerge from the remains of older ones. Matter endlessly rearranges itself into new forms. Nothing truly remains fixed. Even galaxies themselves are temporary. Although they appear eternal on human timescales, galaxies slowly evolve across billions of years. Spiral galaxies gradually exhaust the cold gas needed for new star formation. Their bright blue young stars disappear, leaving older red stars behind. Over time, some galaxies become quieter and dimmer, drifting toward long ages of stellar aging and relative stillness. Astronomers sometimes describe certain ancient galaxies as red and dead. It sounds harsh, yet these galaxies remain beautiful in their own way. Their brightest eras may be over, but they continue shining softly across the darkness with the accumulated light of ancient stars. In the distant future of the universe, most galaxies may eventually resemble these calm elder structures, quieter and colder than the star-forming galaxies we know today. The cosmos itself is aging. This realization emerged only within the last century. For much of human history, many people assumed the universe was eternal and unchanging. But modern observations revealed something astonishing. Galaxies are moving away from one another. Space itself is expanding. The farther a galaxy lies from Earth, the faster it appears to recede. This discovery transformed cosmology forever. It implied that the universe was once smaller, denser, and hotter in the distant past. The galaxies we observe today were once compressed together in an early cosmic state billions of years ago before expansion carried them apart. And remarkably, that expansion is still accelerating. Something unknown, called dark energy, appears to be pushing the universe outward at increasing speed. Scientists still do not fully understand what dark energy is. Like dark matter, it remains one of the great unsolved mysteries of modern physics. Together, dark matter and dark energy seem to compose most of the cosmos, while ordinary matter, stars, planets, oceans, trees, human bodies, represents only a small fraction of reality. It is a strange thought. The familiar universe may be only a thin visible layer atop something far deeper and more mysterious. Yet perhaps mystery itself is part of what makes galaxies so emotionally powerful. Complete understanding often reduces wonder, but the universe continues withholding final answers. Even our most advanced instruments reveal only partial glimpses of what exists beyond human perception. The night sky remains ancient and unfinished. In remote observatories high above clouds and cities, astronomers continue watching galaxies with extraordinary care. Some telescopes orbit Earth itself, free from atmospheric distortion. Others sit in deserts where dry air allows clearer views of the heavens. Massive mirrors gather faint light that has traveled for billions of years before finally reaching human instruments. There is something beautiful about this act of observation. Tiny conscious beings living on a small planet devote entire lifetimes to studying distant galaxies that will never know they were seen. Scientists patiently analyze spectra, brightness, motion, and structure, extracting meaning from faint traces of light crossing impossible distances. Astronomy is, in many ways, an exercise in humility. The deeper humans look into the cosmos, the less central humanity appears, and yet the search continues with remarkable devotion. Perhaps because knowledge itself feels meaningful, or perhaps because the universe awakens a form of curiosity older than civilization. Children often feel it instinctively. At some point, many people look upward and wonder what exists beyond the stars. The question arises naturally, almost automatically, as though the human mind is designed to seek horizons beyond immediate survival. Galaxies become symbols of that longing. Distant, unreachable, but irresistibly real. And despite their immense scale, galaxies can also create feelings of intimacy. The Milky Way is not a distant object viewed from outside. It is home. Every star visible to the naked eye belongs to it. Every ancient myth connected to the night sky unfolded beneath its spiral arms. Every human who has ever lived existed entirely inside this rotating galactic structure without ever leaving it. Human civilization has never traveled beyond a tiny fraction of one galaxy. Even the most distant spacecraft launched from Earth remain incredibly close on cosmic scales. The Voyager probes, drifting outward for decades, have barely begun crossing the outer edges of the solar system. To reach the nearest star using current technology would require tens of thousands of years. Galactic space resists easy travel. The universe appears designed less for movement than for observation. We are able to see astonishing distances long before we can physically cross them. Vision outruns exploration by billions of miles. Perhaps this is why astronomy often feels dreamlike. Galaxies become places the mind visits before the body ever could, and through telescopes, the universe reveals scenes so strange that they almost resemble imagination more than reality. There are galaxies shaped like rings, galaxies with double cores, galaxies torn apart by gravity into luminous streams. Some galaxies contain quasars, brilliant regions powered by feeding black holes so luminous they outshine entire galaxies around them. Others are nearly invisible dwarf galaxies drifting quietly in darkness, with only faint collections of stars to reveal their presence. The cosmos does not repeat itself perfectly. Each galaxy carries scars from its past. Ancient collisions leave ripples in stellar distributions. Bursts of star formation illuminate regions shaped by long-vanished events. Black holes alter galactic centers over millions of years. Every structure visible in deep space is part of an ongoing story still unfolding tonight somewhere in the darkness beyond Earth. Some of these stories began before the Earth itself existed. When astronomers observe ancient galaxies at extreme distances, they are witnessing light released long before the formation of the Sun. Entire galactic civilizations of stars lived and died before our planet was even born. Their supernovas enriched space with heavier elements that later became part of younger galaxies, newer stars, and eventually living worlds like our own. In this way, galaxies inherit from one another. The universe evolves through recycling. Nothing remains isolated forever. Gas drifts between stars. Collisions reshape galactic structure. Ancient stellar remnants seed future generations of planets. Matter travels enormous journeys across cosmic time, changing form repeatedly while obeying the same quiet physical laws. There is comfort in that continuity. The atoms in your body are older than Earth. Some were forged in stars that vanished billions of years ago inside distant ancestral galaxies. Every breath carries material with a cosmic history stretching deep into the ancient universe. Human beings often imagine themselves as separate observers standing apart from nature. But galaxies remind us that separation is mostly illusion. We are not watching the cosmos from outside. We are expressions of it. Perhaps this is why staring into the night sky can produce such unusual emotional effects. People frequently describe feeling both smaller and more connected at the same time. The ego softens, yet existence feels larger and more meaningful. Psychologists sometimes call this the overview effect, when experienced by astronauts viewing Earth from space. Boundaries become less rigid, human conflicts appear temporary, the mind widens beyond ordinary concerns. Galaxies encourage that widening naturally. They stretch perception beyond the scale of daily life. Bills, schedules, arguments, ambitions, all the restless machinery of ordinary existence begins to feel strangely fragile beside structures that have rotated silently through darkness for billions of years. And still, galaxies themselves are only part of something even larger. They gather together into clusters and superclusters linked across vast cosmic webs. Modern surveys of the universe reveal enormous filaments of galaxies stretching through space like luminous threads, separated by gigantic voids where relatively few galaxies exist at all. On the largest scales currently observable, the universe resembles a kind of cosmic network, intricate, spacious, and almost biological in appearance. Gravity shaped this web slowly over unimaginable time. Tiny fluctuations in the early universe expanded into massive structures as matter accumulated unevenly. Galaxies formed along these denser regions, creating chains and clusters spanning hundreds of millions of light-years. Between them lie vast emptinesses so large that a traveler crossing one of these cosmic voids might drift for extraordinary periods without encountering a major galaxy. Even emptiness has structure. This is one of the quieter revelations of modern cosmology. Space is not merely a blank stage upon which galaxies happen to exist. Space itself evolves, expands, bends, and participates in cosmic history. Einstein's theories transformed the understanding of the universe from a static container into something dynamic and alive with geometry. And yet, despite the immense sophistication of modern physics, there remains something deeply ancient about simply looking upward. Long before equations described galactic motion, human beings sat beneath dark skies and wondered. Around campfires, beside rivers, beneath desert stars, people invented stories to explain the glowing band of the Milky Way overhead. Some imagined celestial animals. Some imagined roads to the afterlife. Some believed the stars were holes in a great cosmic shell through which divine light shone. Those myths may not have been scientifically accurate, but they reflected something real about human consciousness. The night sky naturally invites meaning. Even today, in an age of satellites and spectroscopy, galaxies still produce emotional responses that science alone does not fully replace. Knowledge changes the details, but not the feeling itself. In some ways, modern astronomy deepens the mystery rather than dissolving it, because the true scale of reality is far stranger than the ancient myths ever imagined. There are galaxies whose light began traveling toward Earth before multicellular life evolved. There are stars so massive that they burn through their fuel in only a few million years before collapsing catastrophically. There are black holes whose gravitational pull bends light itself into glowing rings. There may even be galaxies permanently unreachable, because cosmic expansion carries them away faster than light can bridge the growing distance. The universe contains horizons that no future civilization will ever cross. This realization emerged from 20th century cosmology almost quietly, hidden inside mathematical equations. Because space expands, distant galaxies are gradually slipping beyond the observable universe. Over unimaginable spans of time, more and more galaxies will disappear from view, their ancient light stretched and weakened until they fade completely into darkness. Future civilizations may inherit a lonelier cosmos. Billions of years from now, observers living inside the merged remnants of the Milky Way and Andromeda may see far fewer galaxies than humans can see today. The evidence of cosmic expansion itself may eventually vanish from direct observation. The universe will appear darker, emptier, and more isolated. And yet tonight, the galaxies are still visible. The cosmos currently exists in a strangely privileged era for observation. Intelligent life emerged at a time when the universe is old enough for planets and biology to exist, but still young enough for distant galaxies to remain observable across immense space. Humanity lives during one brief chapter when the structure and history of the cosmos can still be seen clearly. There is something quietly miraculous about that timing. The stars overhead are not permanent decorations. They belong to a temporary arrangement unfolding across cosmic history. The galaxies visible through telescopes tonight will not always remain visible. The universe changes continually, even when change occurs too slowly for human senses to notice directly. Perhaps this is why astronomy often inspires both wonder and melancholy at once. Beauty becomes more powerful when understood as temporary. A spiral galaxy glows magnificently because billions of stars are alive within it at this particular moment in cosmic time. Someday, many of those stars will fade. Spiral arms will dissolve. Stellar nurseries will empty. Even black holes themselves may eventually evaporate over incomprehensible durations through subtle quantum effects predicted by physics. Nothing lasts forever. And yet the universe seems endlessly creative within that impermanence. New stars continue forming. New planetary systems emerge. Galaxies collide and transform into new structures. Matter never truly rests. Reality reshapes itself continuously across scales so immense that endings and beginnings become difficult to separate. Human life mirrors this pattern in smaller ways. Memories fade. Civilizations change. Generations appear and disappear. People spend their brief lives searching for meaning beneath skies older than imagination. And perhaps one reason galaxies feel soothing is that they place human impermanence inside a much larger rhythm. The cosmos does not resist change, it flows through it. Some astronomers believe there may be more galaxies in the universe than humans once thought possible. Early estimates suggested hundreds of billions. New observations hint that the true number could be far higher, including faint dwarf galaxies too dim and distant for earlier instruments to detect easily. The universe may be overflowing with unseen light, and hidden among those countless galaxies are planets orbiting quietly in darkness right now. Some may be frozen wastelands beneath dim stars. Others may possess warm oceans reflecting unfamiliar constellations. Somewhere, perhaps rain falls beneath skies colored by alien atmospheres, while distant spiral galaxies glow faintly overhead. The thought is strangely calming. Existence may not belong solely to Earth. The universe may contain innumerable quiet worlds living out their own histories in silence across the cosmic sea. And meanwhile, our own galaxy continues its patient rotation. The sun drifts through the Milky Way, carrying Earth and every living thing with it. At this very moment, without sensation or sound, our planet moves through galactic space at extraordinary speed. Oceans rise and fall, cities sleep beneath electric light. Clouds cross continents, human thoughts flicker briefly through billions of minds. And above it all, the galaxy turns slowly in darkness, ancient and immense, carrying us gently through the universe. Most people never feel this motion. Human senses evolved for survival on the surface of a small planet, not for perceiving cosmic movement. Earth feels still beneath our feet. The horizon appears stable, the stars seem fixed in place, and yet everything is moving simultaneously. Earth rotates. Earth orbits the sun circles the galactic center. The Milky Way itself drifts among neighboring galaxies, while the universe expands in every direction. The cosmos is never motionless, even in the quietest moments of night. When a room is dark and the world seems asleep, every person on Earth is traveling through space together at astonishing speed. It happens so smoothly that the nervous system interprets it as stillness. Perhaps this is one of the deepest illusions of ordinary life. The feeling that we are stationary observers in a static world. Galaxies reveal that stillness and motion can exist together. A spiral galaxy appears calm from afar, almost frozen like a photograph suspended in darkness. But inside it, stars orbit continuously. Gas clouds collapse and ignite. Black holes feed slowly on surrounding matter. Entire solar systems drift through invisible gravitational currents. Everything changes, though the changes unfold across timescales too vast for human perception. There is something deeply peaceful about slow transformation. Modern life often accelerates human attention beyond what the mind comfortably handles. Notifications, schedules, headlines, and constant information create the sensation that reality is speeding up endlessly. Galaxies move differently. They remind us of a slower order of existence, one measured not in seconds or days, but in millions of years. To contemplate a galaxy is to enter a different relationship with time. Astronomers sometimes observe stars moving near the centers of galaxies over decades of patient study. Tiny shifts in position reveal hidden gravitational forces shaping their motion. The work requires extraordinary patience. Human beings dedicate entire careers to measuring movements so subtle they are almost invisible within a single lifetime. Science, at its best, often resembles quiet listening. There is a gentle humility in watching the universe carefully rather than demanding immediate answers from it. Telescopes do not conquer galaxies. They receive their light. Astronomers sit beneath dark skies waiting for photons that began traveling long before modern civilization existed. Some of those photons carry astonishing stories. In 2019, humanity captured the first direct image of a black hole's shadow. The image appeared blurry and faint, yet emotionally powerful. For the first time, human beings observed the silhouette of an object once considered almost purely theoretical. The black hole lay inside a distant galaxy called Messier 87, 55 million light-years from Earth. The light used to create that image began its journey before the first human ancestors walked upright. Moments like this reveal something extraordinary about intelligence itself. Tiny creatures living on a rocky planet can use mathematics, instruments, patience, and collective effort to understand objects unimaginably distant from everyday experience. Consciousness, though fragile and temporary, possesses the ability to reach outward conceptually across cosmic space. Perhaps knowledge is one way the universe explores itself, and still, despite every discovery, galaxies retain their emotional mystery. Scientific understanding explains mechanisms, distances, and physical laws, but it does not erase the feeling produced by immense starlit structures drifting through darkness. A galaxy is more than information. It is an atmosphere of scale. This atmosphere changes human thought in subtle ways. Philosophers have long noticed that experiences of vastness often reshape perception. Ancient thinkers standing beneath star-filled skies sensed it intuitively. Modern psychology studies it scientifically. The result is remarkably similar. Awe quiets the constant internal narration of the mind. For brief moments, attention expands beyond the self. Perhaps this is why people often seek dark skies during emotionally difficult periods of life. Grief, uncertainty, loneliness, and anxiety can feel all-encompassing when viewed from within the narrow frame of immediate experience. But galaxies widen the frame. They do not solve human problems, yet they place those problems within a larger and calmer perspective. The universe does not rush. Stars spend billions of years converting hydrogen into light. Galaxies evolve gradually through countless subtle interactions. Even black holes consume matter slowly on cosmic timescales. Nature at its grandest scales unfolds with extraordinary patience, and perhaps patience is one of the hidden lessons of astronomy. In forests, oceans, mountains, and galaxies alike, the deepest processes often happen quietly. Growth remains invisible, moment to moment. Change accumulates gently over time. Human beings, conditioned by urgency, sometimes forget that reality itself moves at many different speeds simultaneously. The galaxies overhead continue their ancient rhythms whether humans notice them or not. There are nights in remote deserts where the Milky Way becomes bright enough to cast faint shadows on the ground. Under such skies, people often report an unusual emotional stillness. The galaxy stretches overhead not as an abstract scientific concept, but as a visible presence, textured, luminous, alive with depth. For most of human history, this was normal. Before electric light transformed civilization, nearly every person lived beneath visible stars. Children grew up knowing the sky intimately. Seasonal movements of constellations shaped calendars, navigation, agriculture, and ritual. The galaxy formed part of ordinary human experience. Modern life has partially hidden that inheritance. In many cities, only a handful of stars remain visible through the glow of artificial light. Entire populations rarely encounter true darkness anymore. Yet the galaxies are still there above the illuminated atmosphere, waiting silently beyond the haze. Sometimes it takes distance to remember scale. Astronauts often describe returning from space with altered perception. Borders appear invisible from orbit. Weather systems move across continents with fluid continuity. Earth itself seems delicate against the surrounding blackness. Many astronauts report feeling less attached to narrow identities and more aware of humanity as a single interconnected species sharing one small world. Galaxies produce a similar effect on the imagination. The Milky Way contains hundreds of billions of stars. Yet from a sufficient distance, even our enormous galaxy would appear as only a thin patch of light among countless others. Human conflicts, nations, economies, and historical eras all unfold inside one tiny region of one ordinary spiral galaxy. This perspective can feel unsettling at first, but over time, it often becomes strangely freeing. Meaning does not disappear simply because the universe is vast. If anything, small moments become more precious against such immense scale. A conversation, a memory, a human life. These things gain emotional depth precisely because they are temporary and fragile inside a universe so ancient and expansive. Galaxies remind us that rarity creates beauty. The conditions required for conscious life may be extraordinarily delicate. Stable stars, heavy elements, planetary chemistry, liquid water, time, and biological evolution all had to align across billions of years. The fact that awareness exists at all may be one of the rarest events in cosmic history, and awareness allows the universe to be experienced. Without conscious observers, Galaxies would still rotate silently through darkness. Stars would still form. Black holes would still bend space-time. But there would be no sensation of wonder, no curiosity, no meaning attached to the light crossing intergalactic space. Somewhere along the history of the cosmos, matter learned to feel. That transformation remains one of the deepest mysteries of all. Science can describe neural activity, chemistry, and evolution. Yet consciousness itself still contains unanswered questions. Why should collections of atoms produce subjective experience at all? Why should the universe contain beings capable of reflecting on existence? Galaxies cannot answer these questions directly, but they frame them beautifully. Far above Earth tonight, ancient starlight continues crossing the darkness. Some photons entering telescopes now began their journeys before humans invented language. Others were released by stars that no longer exist. Light moves patiently through space, carrying traces of distant histories toward any mind willing to look upward and wonder. And hidden among those innumerable stars are worlds forever unknown to us, drifting quietly inside galaxies beyond the edge of human reach. Out beyond those reachable horizons, the universe continues in ways that may never be fully observed from Earth. There are galaxies so distant that their light is already fading beyond detectability, stretched thinner and thinner by the expansion of space. If one could stand inside those galaxies and look back, the Milky Way would appear as it once was, younger and more compact, its spiral arms closer together, its stars more densely packed. Every point in the universe carries its own version of cosmic history, shaped by perspective and distance. In a sense, every galaxy believes it is near the center of things. From within any gravitational system, the universe appears locally stable. Stars orbit quietly, planets circle their suns, and galaxies seem to occupy a meaningful place within a larger structure. Only when viewed on the grandest scales does that illusion dissolve into a vast, evenly expanding cosmos where no single location holds privilege. This is one of the quiet revelations of modern cosmology. There is no true center of the universe in a physical sense. Expansion happens everywhere at once, uniformly stretching space itself. Galaxies are not flying outward from a central explosion point. Instead, space between them is growing, like a surface gently inflating in all directions simultaneously. It is a difficult idea to visualize fully. Human intuition prefers objects moving through space, not space itself expanding. And yet galaxies are not simply traveling through emptiness. They are carried apart by the unfolding geometry of the universe. Even light, the fastest known phenomenon, is slowly caught in this expansion over vast distances, unable to keep all regions permanently connected. Still, within this expanding structure, galaxies retain their internal coherence. Gravity binds them together against cosmic separation. Stars continue orbiting galactic centers in steady patterns. Even as the universe stretches on the largest scales, local systems remain intact, like islands preserving their shape while the ocean between them grows wider. Inside the Milky Way, that stability has allowed time to do something extraordinary. Over billions of years, chemical complexity increased. Simple hydrogen and helium gave rise to heavier elements forged inside stars. Those elements drifted into new stellar systems, forming planets with rocky surfaces and dynamic atmospheres. Eventually, in at least one location, chemistry became biology, and biology became awareness. Galaxies are not only structures of matter, they are engines of transformation. Each generation of stars changes the composition of everything that follows. Early galaxies lacked the ingredients necessary for complex chemistry. Later galaxies inherited enriched material from earlier stellar deaths. In this way, the universe becomes more chemically diverse with time, as though it is slowly learning how to build more intricate forms. There is something almost developmental in this progression, from simplicity to complexity, from uniform hydrogen to structured systems of life-supporting elements, from gravitational collapse to conscious observation. It is not a directed process in any human sense, yet it produces increasingly rich outcomes over cosmic history, and galaxies are the stage upon which this unfolding takes place. Even the empty regions between galaxies play a role. Intergalactic space is not entirely void. It contains thin traces of gas, radiation, and dark matter. Filaments of the cosmic web stretch through it like faint connective tissue linking distant structures together. Within this vastness, galaxies are not isolated objects but nodes in a larger cosmic architecture. Modern simulations of the universe reveal this structure in striking detail. When large-scale models are run using known physical laws, matter naturally organizes into a web-like formation over time. Dense regions collapse into galaxies and clusters. Sparse regions expand into enormous voids. The result resembles a three-dimensional network extending across the observable universe. It is a pattern that feels almost organic, yet it arises purely from gravity acting over billions of years. No guiding intelligence is required, just the cumulative effects of mass attracting mass across space and time. From simplicity, complexity emerges, and within that complexity, galaxies continue to evolve. Some spiral galaxies maintain elegant, well-defined arms for billions of years. Others are disrupted by gravitational encounters, losing their structure and becoming irregular clouds of stars. Collisions between galaxies are not rare in cosmic history. In fact, they are essential to galactic evolution. The Milky Way itself bears evidence of past mergers. Streams of stars orbiting in unusual directions hint at ancient collisions with smaller galaxies long absorbed into its structure. These events did not destroy the galaxy. Instead, they reshaped it, adding new populations of stars and altering its structure gradually over time. Even galaxies grow through interaction. Nothing in the universe develops in complete isolation. Everything is influenced by surrounding gravity, radiation, and motion. Cosmic evolution is fundamentally relational. Structures form through connection, separation, and reconfiguration over time. This idea extends beyond astronomy in subtle ways. Human understanding of systems, ecological, biological, social, increasingly reflects the same principle. Interdependence is not an exception in nature, it is the rule. Galaxies simply express that truth on the largest possible scale. And yet, despite their scale, galaxies are not static monuments. They are dynamic, changing systems moving through cosmic history. Star formation rises and falls, black holes grow and stabilize. Gas clouds collapse or disperse. Over billions of years, each galaxy writes its own evolving narrative in the language of physics. Some of those narratives are nearly invisible. Dwarf galaxies, for example, contain only a small number of stars compared to giants like the Milky Way. They drift quietly through space, sometimes orbiting larger galaxies, sometimes wandering alone in darkness. Though small, they are among the most numerous galaxies in the universe, forming a hidden population that shapes large-scale structure in subtle ways. Even faint structures matter in cosmic architecture, because gravity does not ignore small contributions. Over time, even minor mass distributions influence the motion of larger systems. The universe is sensitive to accumulation. Tiny effects, repeated over vast durations, become significant transformations. This is one of the deeper rhythms of galactic existence: slow influence, building across time until entire structures shift. And while galaxies evolve outwardly, something equally profound occurs within them: the continuous cycle of stellar life and death. Stars are born from collapsing gas clouds. They shine for millions or billions of years depending on their size. Then they end their lives in quiet fading or explosive collapse, returning material to the galaxy. This recycled matter becomes the foundation for future stars and planets. It is a continuous cycle without beginning or end. In that cycle, galaxies act as reservoirs of memory. They preserve the remnants of past stars while simultaneously generating new ones. Every region of a galaxy contains layers of history written in chemical composition, stellar age, and motion. To study a galaxy is to read time itself embedded in matter. And perhaps this is why galaxies feel so profoundly calming when considered slowly. They embody continuity. Change exists, but not abruptly. Transformation unfolds across immense spans, creating a sense of stability within motion. Nothing is rushed. Even violent cosmic events, like supernovas or black hole jets, are spaced across millions of years. From the perspective of a galaxy, even catastrophe is part of a long and gradual unfolding process. And so, as the Milky Way continues its rotation tonight, carrying Earth and every living thing within its structure, it does so without urgency. It turns, as it always has. Stars follow their orbits, gas clouds drift, light moves through dust and darkness, and somewhere deep within its spiral arms, a small planet briefly illuminated by a modest star continues its quiet passage through space, unaware of how large the surrounding architecture truly is. The galaxy does not hurry, and neither, perhaps, does the universe. Across the immense span of galactic time, even what we call the present becomes a thin, almost delicate layer of reality. Light from distant stars is constantly arriving, while other light is already leaving, carrying away information about moments that will never repeat. Every second, galaxies exchange radiation with the wider universe in a slow, continuous conversation that stretches across millions and sometimes billions of years. It is a conversation without sound, but not without meaning. Because in astronomy, light is not just illumination. It is history. It is structure. It is evidence of everything that has ever happened in regions far beyond human reach. When we observe a galaxy, we are never seeing it as it is, but as it was, filtered through the speed of light and the scale of distance. In that sense, the universe is always slightly out of date. And yet, paradoxically, it is also always complete. Every moment exists somewhere in the fabric of cosmic history. A galaxy may have changed long ago, but its older light still travels outward, preserving an echo of its past. The universe does not erase its earlier states. It carries them forward like overlapping layers of time. Modern cosmology has begun to treat time less like a straight line and more like a landscape. Within that landscape, galaxies are not merely objects moving forward. They are evolving structures embedded in a four-dimensional continuum, where past and present are woven together through the geometry of space-time itself. It is a difficult idea to feel intuitively, but there is something almost meditative in it. The sense that nothing is truly lost, only displaced in time. Ancient light still exists, even if it no longer interacts with its original source. It continues outward, faint and patient, crossing the expanding universe long after the events that created it have passed. And somewhere in that faintness lies the structure of galaxies themselves. Because galaxies are, in a very real sense, shaped by light. Radiation from young stars influences surrounding gas clouds. Energy from supernovae pushes matter outward, regulating future star formation. Even the faint glow of older stars contributes to the thermal and chemical balance of galactic environments. Light is not just a product of galaxies, it is part of their internal logic. Without it, galaxies would be entirely different structures. Over time, this interplay between matter and radiation produces patterns of remarkable complexity. Spiral arms, for example, are not rigid structures like physical objects. They are density waves, regions where matter temporarily gathers as it orbits the galactic center. Stars move through these arms, entering and exiting them over millions of years, like travelers passing through slow-moving cosmic currents. From a distance, the spiral appears fixed, but within it, nothing is still. This contrast between appearance and underlying motion is one of the most consistent themes in galactic astronomy. What seems stable is often in motion. What seems simple is layered with invisible dynamics. Even the shape of a galaxy is not permanent, but a temporary expression of gravitational and energetic balance. Galaxies are moments in motion, extended across unimaginable time, and yet they can endure for billions of years, maintaining recognizable structure across epochs longer than most physical processes in the universe. Within those structures, certain regions stand out as especially active. Galactic centers, for example, are often dominated by extreme conditions. Stars cluster densely, gas flows inward under gravity, magnetic fields twist through energetic plasma. At the very heart of many galaxies, supermassive black holes anchor the surrounding motion, shaping the behavior of everything nearby. But even these intense regions are not chaotic in the way human intuition might expect. They follow mathematical patterns. Orbits stabilize. Energy flows along predictable gradients. Even the most violent galactic environments operate under consistent physical laws, repeating over and over across the universe. This consistency is one of the reasons astronomy can exist as a science at all. Despite the unimaginable scale and variety of galaxies, the same fundamental principles apply everywhere. Gravity behaves the same, light travels the same way, atoms interact according to the same rules. The universe is vast, but not arbitrary, and so, across billions of light years, galaxies share a common language. That language is physics. Still, within that shared structure, each galaxy develops its own identity. Some are rich with star formation, glowing with blue clusters of young stars. Others are dominated by ancient red stars, slowly fading as their fuel is exhausted. Some are shaped by recent collisions, their structures stretched and distorted. Others remain relatively undisturbed for long stretches of time. Even among trillions of galaxies, individuality persists. This is a quiet but profound idea. The universe is not uniform repetition. It is variation within constraint, a balance between predictable laws and unpredictable outcomes. The result is a cosmos filled with diversity at every scale, and within that diversity, Earth occupies a very ordinary position. The Sun is not especially large or small. The Milky Way is not especially unusual among spiral galaxies. The chemical elements composing our world are common throughout the universe. In a statistical sense, nothing about our cosmic location appears unique, and yet, from that ordinary position, awareness has emerged. This remains one of the most difficult facts to interpret. The universe does not appear to require consciousness, and yet consciousness exists within it. Galaxies form, evolve, and dissipate regardless of whether they are observed, but observation adds something entirely different. Experience. The universe becomes something that can be known from within, and perhaps that is where galaxies gain their deepest meaning for us. Not as distant objects to be catalogued, but as environments within which awareness itself is possible. They are not simply out there, they are the larger context that made here possible. Every thought occurs inside a galaxy. Every memory is a local event within a vast rotating structure of stars, and even now, as the Milky Way continues its silent orbit, it carries all of human history within a single small region of its spiral arms. Wars, discoveries, civilizations, languages, art, and personal lives unfold like brief flashes of biological complexity on one small world. From the galactic perspective, they are brief indeed. But brevity does not imply insignificance, because meaning is not measured in duration alone. It is measured in depth of experience, in connection, in awareness. A moment does not need to last long to matter. It only needs to be lived. Galaxies provide the stage on which those moments become possible, and as we continue to observe them through telescopes, we are not merely looking outward, we are also extending the boundaries of perception itself. Each image of a distant galaxy is a reminder that reality is far larger than immediate experience suggests. The universe is not limited to what is easily seen. It stretches far beyond the reach of human senses, into regions where light has traveled for longer than life has existed on Earth. And still, that light arrives quietly, patiently, carrying with it the structure of galaxies formed in ancient cosmic eras. Tonight, those galaxies continue their silent rotations, unaware of being observed, unaware of the small planet that has begun to understand them, and yet fully present in their own slow unfolding existence, drifting through the expanding universe with steady, unbroken patience. Some galaxies, however, are no longer drifting quietly. They are colliding. When two galaxies approach each other, the event unfolds so slowly that no single human lifetime could ever witness its full progression. At first, there is only a subtle gravitational disturbance. Spiral arms begin to stretch slightly. Streams of stars shift in gentle arcs. From a distance, both galaxies still appear whole, still recognizable as separate structures suspended in darkness. But gravity does not forget proximity. Over millions of years, the mutual pull intensifies. The galaxies begin to distort, their shapes elongate, as though space itself is being gently pulled apart and reformed. Stars are not solid objects that crash together easily. They are separated by vast emptiness, so most pass by one another without direct contact. But their orbits are altered, their paths are rewritten. What results is not destruction in the usual sense, it is transformation. Two galaxies merging create a new structure entirely. Spiral arms unravel into long tidal streams. Clouds of gas compress, igniting bursts of new star formation that illuminate the collision with temporary brilliance. For a time, the merged system can become more active, more luminous, more chaotic than either galaxy was before. And yet, even this chaos is governed by order. The laws of gravity continue to operate precisely, shaping every arc of motion. Over time, the violent structure settles, stars reorganize into a new equilibrium. What remains is often an elliptical galaxy, smoother, older in appearance, less structured than its spiral ancestors. The universe does not destroy galaxies, it reshapes them. This cycle of collision and reformation has likely occurred countless times across cosmic history. The Milky Way itself is no stranger to it. Evidence written in stellar motion suggests that smaller galaxies have been absorbed into our own over billions of years, their stars still orbiting today as faint reminders of ancient mergers. And far in the future, a much larger encounter awaits. The Andromeda Galaxy, currently moving toward the Milky Way, will eventually become part of this same process. Long before any stars physically collide, the night sky of any observers within either galaxy would slowly change. Andromeda would grow larger and brighter, stretching across more of the sky with each passing million years. Eventually, it would dominate the heavens, but that future lies far beyond human timescales. For now, both galaxies continue their separate rotations, each unaware of the slow gravitational approach shaping their distant destiny. There is a quiet patience in this kind of cosmic motion. No urgency, no suddenness, only gradual convergence across time spans that make ordinary history seem like a brief flicker. Civilizations rise and fall in the interval between even minor galactic adjustments, and yet galaxies are not only shaped by collisions, they are also shaped by absence. Between them lies intergalactic space, regions so empty that they approach the limits of physical nothingness. Temperatures there hover just above absolute zero. Matter is extremely sparse. A single cubic meter of such space may contain only a few atoms, drifting alone across vast emptiness. It is not truly empty, but it is close enough for the distinction to feel meaningful. Within this near emptiness, galaxies appear as isolated islands of structure. Light travels between them for millions or even billions of years, crossing regions where almost nothing exists to interact with it. Photons become silent messengers moving through the largest continuous spaces in reality. And still, even in these voids, there is subtle structure. Filaments of dark matter are believed to connect galaxies across enormous distances, forming part of a cosmic web that underlies everything visible. Galaxies are not randomly distributed. They trace the contours of this invisible framework, clustering along threads of gravitational influence. The universe, on its largest scale, resembles a network, a vast architecture of connection and separation, where matter gathers at intersections and emptiness defines the spaces in between. Within this structure, galaxies act as luminous markers of density. They highlight where gravity has collected matter over billions of years. They reveal the hidden scaffolding of space itself. Without them, the underlying structure would remain invisible. And yet, even this grand architecture is not permanent. The universe is expanding at an accelerating rate. Over immense spans of time, distant galaxies will move beyond the reach of observation. Their light will stretch, weaken, and eventually disappear beyond the cosmic horizon. Future observers may see only their local group of galaxies, with the rest of the universe fading into darkness. The night sky itself will change. This is a subtle but profound consequence of cosmic expansion. The universe is not only evolving in structure, it is also evolving in observability. What can be seen depends on when and where one exists within cosmic history. We are living in a brief window where the wider universe is still visible, a time when galaxies are close enough in cosmic terms for their light to reach us, a time when the large-scale structure of the universe can still be mapped and studied in detail. This era will not last forever, but it is ours, and within this moment, humanity has developed tools capable of detecting galaxies across billions of light-years. Telescopes like the Hubble Space Telescope and newer instruments such as the James Webb Space Telescope have extended vision deeper into cosmic history than ever before. Each image they return is not just a picture, it is a time capsule. A galaxy observed at extreme distance is also a galaxy observed in the past, often in an early stage of development. We see it not as it is now, but as it was when the universe itself was younger. This creates a kind of layered reality. Near galaxies appear as they are in more recent cosmic time. Distant galaxies appear as they were in the distant past. By combining observations across different distances, astronomers effectively reconstruct the history of galaxy formation. It is one of the most remarkable achievements of human understanding. To read the universe not as a static scene, but as an unfolding narrative. And yet, despite all this knowledge, galaxies continue to preserve a sense of mystery. Not because they are unknowable, but because they are so vast that understanding never feels complete. Each answer leads to deeper questions. Each discovery reveals additional layers. Even the simplest galaxy contains enormous complexity. Stars of different ages, gas clouds in various stages of collapse, black holes influencing surrounding motion, dark matter shaping overall structure, magnetic fields threading through interstellar space, every component interacting across timescales ranging from seconds to billions of years. A galaxy is not an object, it is an ecosystem of forces, and like all ecosystems, it is constantly changing while maintaining a recognizable identity. Perhaps this is why galaxies feel so calming when considered slowly. They embody both permanence and change at once. Stability across deep time, combined with continuous internal motion. They are ancient, but never static. And as the Milky Way continues its slow rotation tonight, it carries Earth through this same dynamic structure, a small planet orbiting a modest star, moving through spiral arms filled with light and dust, surrounded by billions of other stars performing the same silent journey. Above it all, the galaxy turns gently through darkness, patient, vast, and endlessly unfolding. Even within this slow and vast rotation, there are regions of surprising calm. Some portions of galaxies experience long periods with relatively little disturbance. Stars there follow stable orbits. Gas clouds remain undisturbed for millions of years. The gravitational environment settles into a kind of quiet equilibrium, where change continues, but only in subtle and gradual ways. In these regions, time feels almost suspended, not because time itself stops, but because nothing dramatic interrupts its flow. No nearby supernovas, no major collisions, no intense bursts of star formation, only the steady presence of starlight, orbiting motion, and the faint gravitational influence of distant structures. The Milky Way contains such regions. Our solar system resides in one of them, far enough from the galactic center to avoid extreme radiation, yet close enough to be enriched by previous generations of stars. It is a balanced position shaped by billions of years of cosmic evolution, and in that balance, life has been able to emerge. But even here, nothing is truly isolated. The galaxy's spiral structure carries us through different environments over vast timescales. In a few million years, the Sun will have moved to a slightly different region of the Milky Way, passing through areas of varying stellar density and interstellar conditions. The galaxy is not a fixed home, it is a journey. Every orbit around the galactic center takes roughly 230 million years. During one such orbit, Earth has experienced the rise and fall of entire biological eras. Continents have drifted, oceans have reshaped themselves, species have emerged and vanished, all while the solar system moved steadily through the same grand rotation. Seen from this scale, biological history becomes intertwined with galactic motion. Life is not separate from the galaxy. It unfolds within its rhythms, and those rhythms extend far beyond Earth. Across the Milky Way, countless planetary systems likely exist, each orbiting their own stars, each embedded within the same spiral structure. Some may be ancient and stable, others may be newly formed, still surrounded by debris disks and early planetary evolution. We do not yet know how many of these systems contain life, but statistically, the abundance of planets in galaxies suggests that worlds are not rare. They are likely common features of galactic structure. The challenge is not their existence, but their distance and invisibility from our current perspective. Even within a single galaxy, separation is immense. The nearest star system to our own is over 4 light-years away. Many stars lie dozens, hundreds, or thousands of light-years apart. Communication, travel, or even simple observation across such distances becomes extraordinarily difficult. A galaxy is densely populated in one sense, but profoundly isolated in another. This paradox defines much of cosmic structure. Things are everywhere, but rarely close enough to interact easily. And yet, interactions do occur. Stars pass near each other over long periods. Gravitational nudges alter cometary orbits. Interstellar clouds drift into new regions, sometimes triggering star formation when conditions align. Even rare encounters leave lasting marks on galactic history. The universe is patient, but not static. Gradual change accumulates into transformation. Nowhere is this more visible than in the life cycle of stars themselves. A star begins in darkness, within a cold molecular cloud composed mostly of hydrogen. Gravity slowly draws this material together until pressure and temperature at the core become high enough to ignite nuclear fusion. At that moment, a star is born, and a new source of light appears within the galaxy. For most of a star's life, it remains stable. A balance exists between the inward pull of gravity and the outward pressure of fusion. This equilibrium can last billions of years for smaller stars like the Sun. During this time, surrounding planets may develop complex environments, potentially including life. Eventually, however, fuel begins to run out. The star changes. It may expand into a red giant, shedding outer layers into space, or collapse into a dense remnant such as a white dwarf, neutron star, or black hole, depending on its initial mass. Each outcome contributes back to the galaxy. The material released becomes part of new generations of stars and planets. Nothing is wasted. Everything is recycled through cosmic time. Galaxies, in this sense, are systems of continuous renewal. Even black holes, often perceived as endpoints, play roles within this cycle. They influence surrounding gas, regulate star formation in certain regions, and eventually may evaporate over extremely long timescales through quantum processes. Nothing in a galaxy exists entirely in isolation. Everything participates in larger patterns of exchange. And as we observe these patterns, a subtle realization emerges. Galaxies are not only physical structures, they are processes unfolding across time. To look at a galaxy is to see not a single object, but a long-duration event. A continuous unfolding of matter, energy, and structure shaped by gravity and time. This perspective changes how distance is understood. A distant galaxy is not simply far away in space. It is also far away in time. Its light represents a version of itself from millions or billions of years in the past, and as that light travels, the galaxy continues to evolve beyond what we can currently see. Every observation is partial, but even partial glimpses reveal extraordinary complexity. Some galaxies appear smooth and symmetrical, others are chaotic and fragmented. Some glow brightly with active star formation. Others appear dim and ancient, composed mostly of older stellar populations. Each one represents a different stage in a vast evolutionary continuum. Across the universe, no two galaxies are identical, yet all are governed by the same underlying principles. This combination of uniform law and diverse outcome is one of the most striking features of cosmic structure. Simplicity at the level of physics produces richness at the level of form, and within that richness, humanity finds itself observing a small species on a small planet, inside one spiral arm of one galaxy among countless others, attempting to understand the structure that contains it. There is something quietly extraordinary about that situation, not because of scale alone, but because of the connection it implies. The same forces that shape galaxies also shape human existence at the most fundamental level. Atoms, gravity, light, and time operate everywhere in the same way. In that sense, galaxies are not distant from us. They are the environment from which we emerged. And as the Milky Way continues its slow, silent rotation through the night, carrying Earth and every living thing within its structure, it does so as part of a much larger story still unfolding. A story written in light across billions of years, a story still being observed, one faint photon at a time. Those photons arrive continuously, even now, in the quiet darkness beyond Earth's atmosphere. Ancient light is entering telescopes, crossing mirrors and sensors, becoming data, images, and understanding. Some of it began its journey before the formation of human civilization, some before mammals existed at all. Yet after traveling unimaginable distances through nearly empty space, it reaches a small planet orbiting an ordinary star and becomes part of human awareness. There is something deeply gentle about that exchange. The universe does not deliver its secrets quickly. It reveals them slowly, through patience, observation, and time. Galaxies do not announce themselves. They simply shine, and for most of human history, that shining remained mysterious. Even after the discovery that galaxies existed beyond the Milky Way, astronomers struggled to understand their nature. Early telescopes showed only blurred shapes and faint spirals. The true complexity hidden within them remained invisible for decades. It was only with improving technology that humanity began to see galaxies in detail, not as vague smudges, but as immense structured systems filled with dust lanes, star clusters, nebulae, and dynamic motion. Every increase in clarity expanded the sense of wonder. The more precisely galaxies were observed, the stranger and more beautiful they became. Spiral arms revealed regions of active star formation glowing pink with ionized hydrogen. Elliptical galaxies displayed dense populations of ancient stars. Colliding galaxies stretched into luminous arcs and bridges under tidal forces. Reality consistently exceeded imagination. This has happened repeatedly throughout the history of astronomy. Each time instruments improve, the universe becomes not simpler, but richer, more layered, more intricate. Human understanding grows, yet mystery remains intact. Perhaps this is why galaxies continue to feel emotionally significant even in a scientific age. Knowledge has not diminished them. It has deepened them. A spiral galaxy viewed through a modern telescope is not less beautiful because its structure can be explained mathematically. If anything, the explanation adds another layer of appreciation. To know that those graceful arms are shaped by gravitational dynamics unfolding across hundreds of millions of years only increases the sense of scale and quiet elegance. Science and wonder are not opposites. At their best, they strengthen one another. And galaxies may be one of the clearest examples of this relationship. They invite analysis and awe simultaneously. They satisfy curiosity while expanding it. The more we learn about them, the more they encourage reflection on time, existence, and perspective. Some philosophers have suggested that astronomy changes not only what humans know, but how humans think. When the universe was believed to consist mainly of Earth and nearby celestial objects, humanity occupied a relatively central position in cosmic imagination. But galaxies transformed that picture completely. Suddenly, Earth became one planet among countless others. The Milky Way became one galaxy among billions. Human existence shifted from central to local, and strangely, this shift did not erase meaning. For many people, it expanded it, because meaning rooted entirely in centrality is fragile, but meaning rooted in participation, in being part of a vast unfolding reality, can feel deeper and more enduring. Galaxies invite that kind of meaning. They remind us that existence is relational, interconnected, and continuous across scales far beyond ordinary perception. Even the smallest human moment occurs within cosmic context, a quiet conversation beneath stars, a child looking through a telescope for the first time, a scientist waiting through the night beside an observatory. These moments are local, intimate events. Yet they happen inside a galaxy rotating through intergalactic space, surrounded by countless other galaxies doing the same. The ordinary and the cosmic coexist constantly. Most of the time, human attention remains focused on immediate concerns: survival, relationships, work, memory, emotion. This focus is natural, but occasionally the mind widens outward and senses the larger framework surrounding ordinary life. Galaxies help create that widening, not through force, but through scale. There is something psychologically soothing about structures so immense that they dissolve urgency. Human stress often emerges from compressed perception, the feeling that every problem is immediate, central, and overwhelming. Cosmic perspective softens that compression. It creates room around thought. The universe moves differently than human anxiety does. Galaxies do not rush. They do not panic. Their transformations unfold across durations so vast that even dramatic events appear graceful when viewed from sufficient distance. A supernova, for example, is among the most energetic events in the cosmos. Entire stars explode, releasing extraordinary amounts of energy and briefly outshining billions of surrounding stars. Yet within the life of a galaxy, even these explosions become part of a larger ongoing rhythm of renewal and recycling. Violence and beauty often coexist in cosmic processes. The same explosion that destroys a star also creates and disperses heavy elements essential for future planets and life. The death of one structure becomes the beginning of another. Galaxies are filled with these cycles of transformation, and perhaps that is another reason they feel calming to contemplate. They embody continuity through change. Nothing remains fixed forever, yet nothing disappears entirely from the larger process. Matter changes form. Light moves onward. Structures evolve. Galaxies persist not because they resist transformation, but because they contain it within their nature. This principle extends even to the universe itself. Cosmologists continue debating the ultimate fate of the cosmos. Will expansion continue forever, leading to increasing darkness and isolation? Could unknown physics alter that trajectory? Are there cycles larger than the observable universe itself? No definitive answers yet exist, and maybe that uncertainty is appropriate. A universe completely solved might feel strangely smaller. But galaxies continue to preserve the sense that reality extends beyond current understanding. Every generation of observers inherits both knowledge and mystery. The night sky remains unfinished. There are still galaxies too faint to detect, structures too distant to resolve clearly, questions about dark matter, dark energy, and cosmic origins that remain unanswered. Humanity has learned much, but the unknown still vastly exceeds the known. And still, the search continues. Across mountaintop observatories and orbiting telescopes, human beings keep looking outward. They study galactic motion, map stellar populations, analyze faint radiation, and reconstruct cosmic history from scattered light. It is one of the quiet triumphs of consciousness, the determination to understand realities far larger than immediate survival requires. Perhaps curiosity itself is part of the universe's deeper structure, not merely a human trait, but a natural consequence of awareness emerging within complexity. Galaxies create stars, stars create planets, planets create chemistry. Chemistry becomes life, and eventually, somewhere within that chain, life begins asking questions about the galaxies that produced it. The circle closes gently. Tonight, the Milky Way continues its vast rotation through darkness, carrying our solar system along one of its spiral arms. Around us drift billions of stars, countless unseen planets, clouds of dust, hidden black holes, and ancient stellar remnants glowing faintly in the cold of space. Beyond the Milky Way lie other galaxies, stretching outward farther than imagination comfortably reaches. And beyond them, more still, an endless architecture of light and distance unfolding quietly across the universe, while on one small world beneath those galaxies, conscious beings continue to look upward and wonder. Wonder may be one of the most natural responses to galaxies, not because they are simply large, but because they exist at the edge of human comprehension. The mind can understand the concept of billions of stars, yet emotionally, Such numbers remain difficult to feel directly. Galaxies occupy a space between knowledge and imagination, where understanding becomes atmospheric rather than fully concrete. You can describe a galaxy mathematically, measure its mass, calculate its rotation, map its structure, and still, something about it remains beyond language. Perhaps this is because galaxies are not experienced in ordinary human ways. No person has ever stood outside the Milky Way and watched it rotate with their own eyes. Much of what humanity knows about galaxies comes through inference, patterns in light, gravitational effects, spectroscopy, radio signals, and decades of careful analysis. In many ways, galaxies are understood through traces. Astronomy is often the science of indirect evidence. Scientists cannot physically touch most of the objects they study. Instead, they interpret the information carried by light across space and time. Tiny shifts in wavelength reveal motion. Faint variations in brightness reveal structure. Invisible gravitational effects reveal hidden matter. From subtle clues, entire cosmic histories emerge. There is something profoundly patient about this method. It requires attention rather than conquest, observation rather than control. The universe offers fragments, and human beings slowly learn how to read them. Galaxies become legible over generations. A single astronomer may devote decades to studying one small aspect of galactic behavior, the movement of stars in spiral arms, the chemistry of interstellar gas clouds, the dynamics of black holes near galactic centers. Knowledge accumulates slowly, layer upon layer, until a larger picture begins to form, and yet the larger picture always remains incomplete. That incompleteness is not failure. It is part of the experience of studying a universe so immense that total understanding may never fully arrive. Galaxies teach a form of intellectual humility rarely found elsewhere. They remind us that reality exceeds certainty. Even now, scientists debate fundamental questions about galactic evolution. How exactly do spiral arms persist over long periods? What is the true nature of dark matter? How did the earliest galaxies form so quickly after the Big Bang? What role do magnetic fields play in shaping galactic environments? The deeper the investigation becomes, the more nuanced the universe appears. Simple models evolve into richer ones. Assumptions give way to unexpected observations. Entire theories are revised as telescopes reveal new details hidden in the darkness. And the darkness itself remains important. Galaxies are luminous, but they are also defined by shadow. Dust clouds obscure starlight. Dark matter shapes motion invisibly. Black holes conceal their interiors behind event horizons from which no information returns. Even interstellar space, though sparse, contains hidden structures detectable only through specialized instruments. Much of the universe exists beyond direct sight. Human vision evolved for survival on Earth, not for perceiving the full spectrum of reality. Radio waves, infrared light, X-rays, gamma rays. These invisible forms of radiation reveal entirely different versions of galaxies when observed with the right instruments. A galaxy viewed in visible light looks calm and graceful. Viewed in X-rays, it may appear turbulent and energetic. Viewed in radio frequencies, hidden structures emerge. Jets from black holes, cold gas clouds, magnetic patterns stretching across enormous distances. The universe changes depending on how it is observed. This realization quietly transformed astronomy during the 20th century. Telescopes no longer relied solely on visible light. Humanity began listening to the cosmos across the electromagnetic spectrum, uncovering layers of galactic complexity previously invisible. In a sense, galaxies became deeper with every new way of seeing them. And perhaps the same is true of reality more generally. The visible surface is rarely the whole story. Beneath calm appearances often exist hidden structures, forces, and histories shaping what eventually becomes visible. Galaxies embody this principle beautifully. Their most dramatic influences are often unseen. Dark matter determines much of their mass. Black holes govern their centers invisibly. Gravitational interactions slowly reshape them across millions of years without producing immediate visible effects. The cosmos is full of quiet causes. Human life often works similarly. Small influences accumulate over time into major transformations. Invisible emotional currents shape decisions. Tiny moments alter entire futures. Gradual changes become profound only in retrospect. Perhaps this is why galactic processes can feel strangely relatable despite their scale. Not because human life resembles galaxies literally, but because both unfold through patterns of slow transformation, hidden structure, and interconnected change. And throughout all of it, time remains central. Galaxies are among the clearest reminders that time itself is not merely a background condition. It is an active dimension shaping everything that exists. Without deep time, galaxies could not form, stars could not evolve, heavy elements could not emerge, life could not appear. Complexity requires patience. The universe did not produce galaxies instantly. It took billions of years for matter to organize into the structures visible today. Every spiral arm, every star cluster, every planetary system represents accumulated history compressed into form. When humans look at galaxies, they are witnessing the result of ancient processes still unfolding. This can create an unusual emotional sensation, a mixture of calm and vertigo. Calm because galaxies move with such steady grandeur. Vertigo because they reveal scales of time and distance far beyond ordinary intuition. And yet the mind adapts surprisingly well. Given enough quiet attention, even cosmic vastness begins to feel less alien. The brain gradually accepts that Earth is part of a galaxy, that galaxies fill the universe, and that human existence unfolds inside this immense architecture naturally, not exceptionally. The cosmos stops feeling distant. It becomes context. This shift may be one of the most profound effects astronomy can have on perception. The realization that the universe is not something separate out there, but the larger environment within which all experience occurs. Every human memory happened inside a galaxy. Every work of art, every scientific discovery, every moment of joy or grief unfolded beneath ancient stars orbiting through the Milky Way. Human history is not detached from cosmic history. It is a local chapter within it, and the galaxy itself continues onward regardless. Long after current civilizations disappear, the Milky Way will still rotate through darkness. Stars will continue forming in cold molecular clouds. Others will fade into stellar remnants. New planetary systems will emerge from recycled material left behind by older stars. The process is continuous, not hurried, not directed toward a final goal. Simply unfolding according to the deep rhythms of physics and time. There is something profoundly soothing in that continuity. The universe does not depend on any single moment to continue existing, and yet every moment still participates in the larger unfolding. Human lives are brief compared to galaxies, but brief things can still belong to vast systems meaningfully. A single note can belong to a symphony. Tonight, above Earth, the galaxies continue shining across unimaginable distances. Their light moves patiently through expanding space, crossing cosmic darkness one photon at a time. Some of that light is entering human eyes at this very moment. Ancient light, galactic light, light that began traveling long before modern civilization existed, finally arriving here after crossing the silent architecture of the universe. And somewhere within that immense and ancient darkness, the galaxies continue turning. They turn without sound. In the vacuum between stars, motion produces no roar, no rushing wind, no echo of rotation. A galaxy can spin for billions of years in complete silence, its stars moving through darkness with only gravity guiding their paths. To human imagination, such immense motion often feels as though it should create some enormous cosmic noise. But space remains quiet. This silence is part of what makes galaxies feel dreamlike. Everything about them is immense beyond ordinary experience, yet their existence unfolds in stillness. Entire systems of stars drift through intergalactic space without disturbance. Supernovas erupt with energies beyond comprehension, yet no sound travels outward through the vacuum to announce them. The universe is visually dramatic but acoustically calm. Perhaps this contributes to the strange emotional atmosphere of astronomy. Galaxies inspire awe, but not urgency. They seem distant from the frantic pace of ordinary life. Their rhythms belong to another scale of existence entirely. And still, despite that distance, humans continue feeling emotionally connected to the night sky. Part of this connection may come from evolution itself. For most of human history, survival depended partly on attention to celestial patterns. The stars marked seasons, guided navigation, and structured time. Long before writing, the sky served as humanity's oldest map and calendar. The galaxy overhead was not decoration. It was presence. Generations lived beneath it without fully understanding what they were seeing. Yet the emotional relationship remained powerful. Ancient people told stories about the Milky Way because human consciousness naturally seeks meaning in vastness. The glowing river of stars crossing the darkness demanded interpretation. Science eventually changed those interpretations, but not the impulse behind them. Even now, many people encountering a truly dark sky for the first time experience something difficult to describe. A sense of scale enters awareness physically, almost emotionally. The stars no longer appear as scattered points, but as depth itself, layers of light extending far beyond intuitive comprehension. Galaxies reveal that the universe has texture. Darkness is not empty. It contains structure, distance, history, and motion. Every faint point of light belongs somewhere within a larger cosmic arrangement. Some stars lie relatively nearby within the Milky Way. Others are entire galaxies so distant that their combined billions of stars appear as a single dim glow. Human eyes evolved to perceive survival-scale reality. Yet under the night sky, those same eyes encounter cosmic-scale existence. Perhaps this is why astronomy often feels both intimate and overwhelming at once. A person standing alone beneath stars experiences something deeply personal. Yet the objects overhead belong to systems unimaginably larger than individual life. The mind stretches between these scales, and in that stretching, something softens. Modern psychology has increasingly studied the effects of awe on human thought and emotion. Experiences of vastness, whether natural, artistic, or cosmic, tend to reduce obsessive self-focus temporarily. People become more aware of connection, continuity, and shared existence. Galaxies naturally produce this effect, not because they diminish humanity, but because they reposition it within a larger framework. They remind us that existence is broader than immediate concerns, deeper than daily routines, and older than civilization itself. There is peace in remembering scale. A galaxy does not erase human emotion. Love, grief, memory, fear, hope, these remain deeply real experiences, but cosmic perspective changes the atmosphere around them. Problems feel less absolute when viewed against billions of years of galactic history. The universe becomes a kind of emotional horizon, and horizons have always affected the human mind. Oceans, mountains, deserts, forests, large environments alter perception because they exceed ordinary boundaries. Galaxies are simply the largest horizon of all. Yet, unlike mountains or oceans, galaxies cannot be fully experienced directly. No human has traveled outside the Milky Way. No spacecraft has even approached another star system. The scale involved is simply too great for current technology. Humanity's relationship with galaxies remains primarily observational and imaginative, and perhaps that distance preserves some of their mystery. Things fully accessible often lose part of their imaginative power. Galaxies remain partly unreachable, existing beyond direct physical experience. We know them through light, mathematics, images, and thought. They become landscapes of the mind as much as physical objects. Science fiction has explored this territory for generations. Writers imagined civilizations spread across spiral arms, interstellar travelers crossing galactic distances, and ancient species older than planets themselves. These stories reflect a deeper truth about galaxies. They expand the imagination naturally. Once humans understood that the universe contained billions of galaxies, reality itself became more spacious psychologically. Possibility widened. Even if humanity never travels far beyond the solar system, The knowledge that galaxies exist changes consciousness. It alters how existence is framed internally. The universe stops being a small, enclosed system and becomes an open, evolving vastness, extending beyond immediate comprehension. This realization arrived gradually in human history. For ancient civilizations, the stars were local features of the sky. For modern astronomy, they became distant suns. Then galaxies expanded the scale again, transforming the Milky Way from the universe itself into one structure among countless others. Each expansion reduced certainty while increasing wonder, and perhaps this process continues indefinitely. Every time humanity believes it has reached the edge of understanding, the universe reveals additional layers beyond it. Dark matter, dark energy, black holes, cosmic inflation, quantum uncertainty. The deeper astronomy progresses, the stranger reality becomes. Galaxies sit at the center of many of these mysteries. They rotate too quickly based on visible matter alone. They evolve differently depending on environment and history. Some contain active galactic nuclei producing extraordinary energy. Others remain faint and diffuse, barely detectable against the darkness. No single galaxy represents the whole universe. Each reveals only one expression of cosmic possibility, and this diversity itself is calming in a subtle way. The universe does not insist upon uniformity. It allows variation within underlying laws. Galaxies can become spiral, elliptical, irregular, giant, dwarf, active, quiet, ancient, or newly formed. Reality contains room for many forms. Perhaps human beings respond positively to this, because life itself also depends on variation, adaptation, and evolving complexity. The cosmos does not appear rigidly mechanical when viewed deeply. It appears dynamic, relational, and continuously unfolding. Galaxies embody that unfolding beautifully. They are not finished objects suspended permanently in space. They are ongoing processes, rivers of stars moving through gravitational fields, ecosystems of gas, dust, radiation, and time, histories still being written across billions of years, and within those histories, Earth occupies only a tiny moment. The dinosaurs existed for a longer period than human civilization has existed so far, yet even their era represents only a fraction of one galactic orbit around the Milky Way's center. The galaxy has turned slowly through countless biological ages without interruption. Long after humanity changes or disappears, it will continue turning. New stars will ignite, others will fade. Molecular clouds will collapse into future solar systems. Ancient stellar remnants will drift silently through interstellar darkness. The cosmic story continues regardless. Yet somehow, this does not make human life meaningless. If anything, galaxies suggest the opposite, because within all this vastness, consciousness emerged. Awareness appeared. The universe became capable of reflection through living minds. That fact alone gives human existence a strange and beautiful significance, not despite cosmic scale, but within it. And tonight, while the galaxies continue their silent rotations through the darkness beyond Earth, billions of human beings sleep, dream, wonder, remember, and look upward beneath the same ancient sky. Above those sleeping cities and quiet landscapes, the Milky Way continues to arc across the night like a memory older than Earth itself. Most of its stars are invisible to the naked eye. Human vision captures only a small fraction of the galaxy's true population. Hidden within the darkness are dim red dwarfs, ancient white dwarfs slowly cooling over billions of years, neutron stars spinning silently through space, and black holes drifting unseen between the stars. The galaxy contains far more than light alone reveals. In fact, much of existence appears hidden from ordinary perception. This is one of the recurring lessons of astronomy. Reality is deeper than immediate appearance suggests. Telescopes, mathematics, and patient observation continually uncover layers previously invisible, and every new layer changes the emotional texture of the cosmos. Once, the night sky seemed relatively simple, stars arranged against darkness. Then galaxies revealed themselves. Then dark matter, then black holes, then exoplanets orbiting distant stars. The universe became progressively more populated, more dynamic, more alive with unseen structure. Silence remained, but emptiness disappeared. Even the dark spaces between stars are filled with thin gases, drifting dust, magnetic fields, radiation, and faint gravitational influences extending across enormous distances. Space is not a void in the absolute sense. It is an environment, subtle, sparse, but active. Galaxies breathe through this environment. Gas flows inward toward regions of star formation. Stellar winds push material outward. Supernovas enrich surrounding clouds with heavy elements. Black holes generate jets that extend across thousands of light years. Every galaxy participates in exchanges of matter and energy continuously, and yet, from afar, they still appear serene. This contrast between underlying complexity and outward calm may be one reason galaxies feel so soothing to contemplate. They embody hidden activity beneath visible stillness, much like oceans viewed from great height, or forests moving quietly in wind. Complexity does not always announce itself loudly. Sometimes the deepest processes unfold gently over immense spans of time. The stars themselves demonstrate this beautifully. Most stars spend the majority of their existence in stable equilibrium, steadily converting hydrogen into helium through nuclear fusion. The Sun has been doing this for roughly 4.5 billion years, and will continue for several billion more. Human civilization arose during a tiny fraction of one ordinary star's lifespan. This perspective alters the emotional scale of history. Entire eras that feel ancient to humanity, empires, languages, migrations, inventions, become brief atmospheric moments beside stellar and galactic durations, and still, those moments matter. Galaxies do not diminish human life by being vast. They contextualize it. They place ordinary existence within a larger continuity, reminding us that transience and significance are not opposites. A sunset remains beautiful even though it fades. A human life remains meaningful even though it is brief compared to the stars. Perhaps galaxies help reveal this more clearly because they operate on such enormous scales that permanence itself becomes relative. Even stars die. Even galaxies change. Even the universe evolves. Nothing static lasts forever, but continuity persists through transformation. The matter composing living beings today once belonged to ancient stars. Future stars and planets will form from material existing now. Galaxies recycle themselves endlessly, turning death into renewal through cosmic chemistry. This cycle unfolds with extraordinary patience. A molecular cloud may drift for millions of years before collapsing into stars. A star may shine for billions of years before shedding its outer layers back into the galaxy. The galaxy itself may continue rotating long after entire species and civilizations have disappeared. Time in the cosmos behaves almost like weathered stone, slow, immense, and indifferent to urgency. And perhaps that is part of why astronomy can feel emotionally restorative. It introduces scales too large for panic to survive comfortably within them. Human concerns remain real, but they stop feeling absolute. The galaxy has existed through unimaginable change already. Continents shifted, species evolved, ice ages came and went. The stars continued their motion overhead throughout it all. The Milky Way remained present before humanity appeared and will remain long after. This continuity can feel strangely reassuring, not because the universe protects human life from suffering or loss, but because existence itself extends far beyond any single moment. Galaxies suggest that reality is larger, deeper, and more enduring than immediate experience alone reveals. Even darkness becomes less frightening when understood cosmically. Interstellar space may appear empty and cold, yet it is also the birthplace of future stars. Darkness in astronomy is often not absence, but potential. Molecular clouds obscure light because they contain the raw material for future solar systems and planets. Some of the darkest regions of galaxies are also the most creative. Within dense clouds hidden from visible light, gravity slowly gathers matter together until new stars ignite. Entire planetary systems begin inside these concealed environments, invisible at first, then gradually emerging into illumination. There is something quietly hopeful about this process. Creation often begins in places not yet visible, and throughout the universe, Galaxies continue repeating these cycles endlessly. Stars form, stars die, matter disperses and regathers. New structures emerge from ancient remnants. The cosmos wastes very little. Even black holes, despite their reputation as devourers of matter, participate in larger cycles. Their gravitational influence shapes galactic centers. Their energetic jets affect surrounding gas. Some may eventually evaporate through processes so slow they extend beyond ordinary comprehension. Everything belongs to time. Galaxies teach this gently. Nothing escapes change, yet change itself becomes part of a larger continuity. The universe remains dynamic without becoming chaotic. Order emerges naturally through physical law across immense durations. This realization changed humanity profoundly. For centuries, many people viewed the universe as static and unchanging. Modern astronomy revealed instead a cosmos alive with evolution, movement, and transformation. Galaxies became evidence that reality itself has a history, a beginning, a development, perhaps even an eventual fate. And still, despite all this motion and transformation, the night sky often feels peaceful when viewed directly. A person standing beneath stars rarely experiences the universe as violent or unstable. Instead, it feels calm, expansive, and deeply quiet. Maybe because human perception encounters galaxies primarily through light, gentle light crossing impossible distances, light softened by time and space before reaching Earth. Ancient photons arriving silently after journeys lasting millions or billions of years. There is tenderness in that persistence. The universe continues sending its light outward endlessly, whether anyone observes it or not. Galaxies shine simply because that is what stars do. No audience is required, and yet audiences emerged anyway. Conscious beings evolved beneath those stars and began wondering about them. They invented telescopes, observatories, mathematics, and theories to better understand the glowing structures overhead. Slowly, patiently, humanity learned that the Milky Way was not the whole universe, but one galaxy among countless others. The discovery was humbling, but also liberating, because once the universe became larger, imagination expanded with it. Human thought stretched outward into scales previously unimaginable. Galaxies transformed not only astronomy, but philosophy, psychology, and the emotional sense of existence itself. The cosmos became open, and tonight, while Earth continues its quiet rotation beneath the stars, the galaxies remain scattered across the darkness beyond. Immense rivers of light drifting through expanding space, carrying within them the histories of stars, planets, and perhaps even other conscious minds looking back into the same infinite night. If other minds do exist among those distant galaxies, they too may feel the same strange pull toward the stars. Perhaps somewhere on a world orbiting another sun, beneath a different arrangement of constellations, conscious beings have looked upward and wondered about the glowing structures beyond their own galaxy. They may have developed their own mathematics, myths, observatories, and philosophies. They may have experienced the same mixture of curiosity and humility that arises naturally when intelligence encounters cosmic scale. Or perhaps the universe is silent, except for Earth. No one yet knows. This uncertainty remains one of the deepest emotional undercurrents in modern astronomy. The Milky Way contains hundreds of billions of stars, many with planets. The observable universe contains countless galaxies. Statistically, life elsewhere seems plausible, yet the silence persists. Astronomers call this tension the Fermi paradox. If life is common, where is everyone? There are many possible answers. Intelligent civilizations may be extraordinarily rare. They may exist but remain separated by distances too vast for meaningful communication. They may arise and disappear quickly on cosmic timescales. Or perhaps advanced civilizations simply lose interest in broadcasting their existence outward into the galaxy. The universe offers no clear reply, only silence, distance, and possibility. And yet even that silence has its own atmosphere. It transforms galaxies into places of quiet speculation. Every distant star system becomes a question mark suspended in darkness. Every potentially habitable planet carries the faint possibility of oceans, weather, memory, language, or awareness unfolding beneath unfamiliar skies. The imagination naturally moves into these spaces because galaxies are not merely astronomical objects. They are containers of potential histories. Worlds may rise and vanish inside them unnoticed by the rest of the universe. Entire civilizations could bloom beneath stars no human will ever see directly. The scale involved almost guarantees hidden stories, and perhaps there is something comforting in that idea. The universe may be filled not only with matter and energy, but with experiences unfolding independently across unimaginable distances, different forms of life, different understandings of reality, different ways of interpreting the same stars, or perhaps consciousness itself is exceedingly fragile and rare. In that case, Earth becomes even more precious. Either possibility deepens the emotional significance of galaxies rather than reducing it. Whether life is abundant or uncommon, the cosmos remains a place where awareness emerged against extraordinary odds, and awareness changes everything. Without conscious observers, galaxies would still rotate through darkness exactly as they do now. Stars would continue forming, black holes would continue bending space-time, but there would be no wonder attached to any of it. Consciousness transforms physical existence into experience. A galaxy becomes not only a structure of matter, but something seen, felt, imagined, and contemplated. Through awareness, the universe acquires interiority. This may be one of the strangest facts of all. The cosmos produced beings capable of emotionally responding to its own existence. Matter organized itself into minds that look outward and feel awe toward the galaxies from which that matter originally emerged. In this sense, galaxies are observing themselves through us, not literally, perhaps, but conceptually. The connection runs deep. The calcium in human bones, the oxygen in human lungs, the iron in human blood, all were forged inside stars within galaxies long before Earth existed. Human life is made from galactic history. Every heartbeat depends upon ancient stellar processes. Every breath carries atoms recycled across cosmic time. Even the neurons producing thoughts and dreams are built from material born in stars that vanished billions of years ago. Galaxies are not distant from human existence. They are ancestral. This realization can change the emotional texture of the night sky entirely. The stars stop feeling separate. The universe stops feeling cold in the abstract sense. Instead, reality begins to feel interconnected across immense scales of time and structure. The cosmos becomes less like a machine and more like a continuum, not alive in the biological sense, but deeply relational. Everything emerges from prior processes. Stars create elements, elements create planets, planets create chemistry, chemistry creates life, life creates awareness. Awareness looks back toward the galaxies. The chain remains unbroken, and throughout all of it, time flows steadily onward. The galaxies visible tonight are already changing, even though those changes remain invisible within a human lifetime. Stars are forming in hidden molecular clouds. Others are collapsing into remnants. Black holes are slowly feeding on surrounding gas. Entire spiral arms continue their rotation around galactic centers. Motion exists everywhere. Yet from Earth, the stars appear calm and nearly fixed, preserving one of astronomy's oldest illusions. Ancient civilizations often believed the heavens were eternal and unchanging because human lifespans are too short to easily perceive cosmic evolution directly. But the universe is not static. It breathes through epochs. Galaxies slowly drift apart through cosmic expansion. Clusters interact gravitationally. Light stretches as it crosses expanding space. Even the background radiation left over from the early universe cools gradually over time. Everything evolves. And perhaps this universal change explains why galaxies feel emotionally resonant to human beings. Human life is also shaped by impermanence. Memories fade, bodies age, relationships transform, entire societies shift across generations. Nothing remains exactly as it was, yet continuity persists through those changes. Identity survives transformation. Meaning survives impermanence. Galaxies demonstrate this on a cosmic scale. Their stars come and go, their structures evolve, Yet recognizable patterns endure across billions of years. They are stable through motion. There is wisdom in that balance. Human culture often imagines peace as the absence of change, but the universe suggests something different. True stability may come not from resisting transformation, but from participating in larger rhythms that continue beyond any individual moment. Galaxies do not fear becoming different. They simply evolve. And perhaps that is one reason the night sky has comforted people across history. Beneath the stars, human beings sense something enduring without needing permanence in every detail. The galaxy overhead changes too slowly to threaten immediate existence, yet dynamically enough to feel alive rather than frozen. It becomes a companion to human thought, a silent one, certainly, but a profound presence nonetheless. Tonight, while Earth turns beneath its atmosphere and oceans continue their tidal motions beneath the moon, the Milky Way stretches outward in all directions around us. Billions of stars orbit quietly through the galactic disk. Nebulae glow softly in hidden regions of space. Ancient clusters drift through the halo surrounding the galaxy. Farther still, beyond the Milky Way, other galaxies continue their own silent journeys through the expanding cosmos. Some spiral gracefully in isolation. Others collide and merge. Some burn brightly with active star formation, while others fade slowly into quieter ages. Across the universe, countless galactic histories unfold simultaneously in darkness too vast for ordinary intuition to fully hold. And yet the light from those galaxies continues arriving here, crossing millions and billions of light years with patient persistence until, eventually, it reaches human eyes, human instruments, and human imagination beneath the quiet sky of one small world.